Okay, first question. A teenager walks 5 kilometers west. So I'll go draw my little north, south, and then I spell the word we. All right, 5 kilometers west. 5 kilometers west. Then he realizes he drops his phone. So we're going to call this point A. He realizes, drops his phone, and he walks 2 kilometers back. You know, technically he retraces his steps. So those arrows, you know, it should be like right, you know, right here. Okay. And that's your B location. Clean that up right there. That's your B location. Try that. There you go. That's your B. So here's your B location. So you went from here to here. What's the final resultant arrow? Here's your A, here's your B arrow. Man, I gotta wait for that to dry. So your B arrow is 5 minus 2. What direction? You were at A and you're heading towards B. So you're still going west. So 3 kilometers west. So you were going west, you walk back, you went east, but your final resultant is from that location. So that number. What's the total distance you walked? So that was 3 kilometers from point A, your initial point. What's the total distance? Well, that's what you walk. You walk 5 kilometers west plus 2 kilometers east, and you don't care about distance. You just add them up. 7 miles, and which you walk, well, you didn't really walk 7 miles west or east because you did kind of both. So it's just 7 miles, no direction. Height of a doorknob, what's 10 to the 0? 10 to the 0, you plug that into your calculator. I can't remember how to plug it into my calculator. This is like the only time you're not using that second EE button. You're going to put 10, because there's no like times 10 to something. It's just 10 to the power of 0. So I put that, 0. Answer's 1 meter. 1 meter. So what's this one? This one's 10 meters. That's pretty large. What's this one? That's 100 meters. What's 10 to the negative 1? Oh, I forget. Let's just plug it in. 10. Arrow. Negative. Down here, that negative 1. 0.1 meter, which is kind of like 10 centimeters. So, all right. Gives you an idea. All right, now the length of the bus is closely related to, hopefully you know that's like 100. 100 meters? Yeah, that would be like a football field. Or, you know, soccer field or whatever like that. I hope it's like 2 field. Football field. Or a soccer field or something like this. But this is 10 meters. That's close. There's a little poster in the classroom too for that. All right, number 4. What's the rules? You got to list your variables. Must show the given variables with the correct units. And then you write the equation, and then you show some proper substitution in order to see full credit. Circle your final answer. A dog runs in a straight path chasing a ball. The dog has an average velocity, so V average. Do you really care? Yeah, maybe. I don't know. Let's just put it down. 6 meters per second. It took the dog 5 seconds. There's my time. To reach the ball, what was the distance? D equals what? So I'm going to give you like 2 things, and you don't know what D is. I got to get my reference table. So I only have 3 things, and I've been working with 2 equations. So basically, we're working with these 2 equations for the test. This one is basically that one, just in a different format. All right, so I have 3 things. 1, 2, 3. Yeah, let's use this one. I have D and T. I'm looking for D. I know what that is and I know what T is. So let's just solve for it. Write your equation. That's part of the rules. V average equals D over T. Because, you know, it probably will slow down and sped up, but we all cares about that the normal pace was about 6 meters per second. Plug in what we know and what we don't know. I'm trying to solve for D. So there's 2 ways you can do that. You can plug this information in right now. 6 meters per second equals D times D we don't know, and then T is 5 seconds. Then you have to multiply by 5 seconds both sides. I need the seconds. and I'm multiplying it by both sides. Dot there. These kings cancel out. And I'm left with, I suppose I was not supposed to be writing in pink. Darn it. D, because I write the single variable on the left. 5 seconds times 6 meters per second. Seconds over 1. Seconds cancel out. Answer is 30 meters. All right. Oh, the other way to do it, which I like, is to take this equation and solve for D right away. So I multiply T by both sides, and then I just say D equals VT, which is basically what you put over here. You multiplied your velocity, 6 meters per second, 6 meters per second, times your 5 seconds, and your answer still is 30 meters. Seconds cancel out, 6 times 5. Both answers, both ways. All right, now it says, what is the time it takes my dog, well, sorry, we're gonna read it. What is the time it takes my son's car to go from rest to 35 in a uniform acceleration? So T is what I'm looking for. From rest, my V initial is 0. Saw that one, that's not obvious. There you go. That's what that is, rest. 2, the V final, 35 meters per second. And then my A, I got to write A somewhere. A is 2.3 meters per second squared. So we're going to use this equation. Now, what's the change in velocity? Hopefully you remember that from class. Is V final minus V initial. There's your change. Time. So now part of the rules are you must write the equation. So now I write my equation. A equals V final minus V initial T. What do I know? This one goes to 0. That's 0. So now I have A equals V final T. Trying to solve for T. And I like to flip it right now. It just makes it, easier for me. So T equals V, so you're just flipping those, divided by A. That's V final. So V final is 35 meters per second divided by A, 2.3 meters per second squared. $35 divided by 2.3, and I got 15.2. Now I know the time is in seconds. I'm going to put the word seconds because I don't want to make it look bad. But yeah, I'm supposed to circle the answer, right? Here's my unit study. I'm studying my units. Does a meter per second divided by a meter per second squared, does that give me seconds? I don't know. Let me try to look. Does that work? Let's just check. So that's what these units are. Meter per second divided by meter per second squared. That division is right here. Rules of engagement are rules of mathematics. Bang it. Flip the fraction. S squared over M. M's cancel out. Bang, bang. 1S down here cancels with 1S out here. Final unit, seconds. Is that what we got? Yep. Cool. It's the dance of units. Mental analysis at its finest. All right, what's the next one? What is the final velocity of a roller coaster that has initial velocity of 0? We're looking for V final. We don't know what that is. And the acceleration is 17 meters per second squared. Oh, do we have everything we need? Darn it. Bummer. I forgot to put this in. Need time. Let's do in 5 seconds. We need time. I got to tell you that in class. Oof. Sorry, guys. I printed this out pretty fast because I figured the photocopier was going to run out of paper. So 5 seconds. All right, now you got to write your equation. I'm going to write A equals V final minus V initial over T. Plug in what you know and what you don't know. This one's 0. So now I have A equals V final over T, solve for V final, multiply each side by T. Those cancel out. Write the V final on the left side. V final equals, and you can multiply it in any order. I put A and then T. Pretty common. So 17 meters per second squared times 5 seconds. That unit could be like seconds over 1. One of those seconds cancels out with one of those seconds. My unit is going to be meters per second. I go 17 times 5 is 85 meter per second. There you go. Voila.